Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Well, I'm back. It's been a while, I have to admit, much longer than the absence is much longer than I initially thought or hoped. But yeah, I had an air show to organize. Unfortunately, it didn't end well with a fatal crash. So that took a bit longer than I expected just to finish, and we're still busy with investigations and all sorts of things. But anyway, that's beside the point. I have eventually got some time, so I can again continue with my channel. So welcome to my channel, View from Space. For those that haven't been to my channel, it's all about remote sensing and the application of remote sensing. And I hope you enjoy my channel. Also, welcome to join me on Facebook page. I post all sorts of nice little things on my Facebook page. So welcome to join me. And then please, on this video, like, subscribe, share. Really appreciate your support. And then, yeah, help me to get to the magical numbers by like, subscribe, put it on playlist, let it run, etc. Okay, so it's been a while. 4 months ago, can you believe it, that I did our last video on remote sensing and Earth Engine. And so we did a series where we looked at image classification. And I'm not going to go for all the ins and outs there, but basically we ended with accuracy assessments of our various image classifications to get a sense of what methods, techniques seem to do the job the best. And one that we haven't touched on is object-based image classification. So what we've done here is pixel-based. So we looked at pixels and classify the image based on the pixels. What we're going to do now is work on what we call object-based image classification. So we don't look just at the value of the pixels or the spectral signature of each pixel. We actually look at the call it the texture or the size or whatever of the pixel itself. So we add an initial step there. Okay, so it's called object-based image classification. Okay. So in our quest, let's go to our QGIS. So in our quest for object-based image classification, we actually follow a couple of steps that we don't do in the normal pixel-based classification. Remember, this is our interface with QGIS. There is some of our pixel-based classification. There's our supervised classifier. There is our classification tool. There's our SCP doc. There is our neural network classifier, and in OTB we have also classification that we've gone through. Or is it in the white box? Either one of the two. I think it's in white box that we have image classification. Nonetheless, there's various techniques there for pixel-based classification. Okay, so there's various methods or techniques or plugins or programs for that. Okay, and we've done all of them. Okay? We've done all of them in the previous set of tutorials and videos. This one, as I said, is called object-based image classification. And the idea is that we identify pixels that have similar, not spatial signatures, but textures or sizes or shapes. For example, they all are rectangles and things like that. Okay, but we'll get to that. You'll see how we get there. So the first step in this is, and for this we're going to use the OTB plugin. Okay, the Ethereal plugin. We're going to use this one here. And again, you can go to plugins, manage and install plugins, and you're going to go all, and we're going to search for OTB. And there it says the Orfeo Toolbox provider. There it sits. Okay, so you just install it. Okay, you just install it. We're going to close it, and it should sit with there. And if you're not sure, also you can go to settings, you can go to options, and then within options you go to processing there at the bottom, and then you go to providers. You'll see it also sits in there. Okay, and you can reference it to your folder, etc., etc. But that should be fairly straightforward. It should automatically load here when you install it. But if you have problems, just have a look here in your folder, application folder and folder. There's where your codes and scripts and all these things sits in. Okay, so we need the OTB, the Orfeo toolbox we need for image classification, object-based image classification. So that's the first thing. We need the OTB. Okay. So obviously we have our image, and this is obviously our stacked raster. And just to go back to, if we go to our SCP, we have stacked our we have stacked it, band 1, 2, 3, 4, 5. Remember, we're working with Sentinel. And so we've stacked it. It's setting the whole screen. That's interesting. Why is it doing the whole screen now? Let's just make it a bit smaller. It shouldn't set the whole screen. So there's our Sentinel bands 1 to 12. And as I said, we have classified it as a Sentinel-2. There's a center wavelengths, etc., etc. And basically, we just go here, press there, create raster bands or set or stack bands. So basically, it just combines all these individual bands in a stack raster. And that's as simple as you go. Remember, and I'm not going to go back how we got to the Sentinel bands, but we basically downloaded it from the website. We've brought it into QGIS, we clipped it, etc., etc. And then we have all these individual bands. And then we use the semi-automatic classification plugin to create a virtual raster of the bands and a stack that is essentially exactly the same thing. Okay, so that's in short what we've done. And then we display it in the natural colors, which is band 2, 3, and 4. So that's our natural color of our region of interest, image of our region of interest. Okay. Remember, we also have already created our training where samples where we've initiated, I think it was 4 or 5 farming, mountain, sand, urban, felt, and water. That's right. Okay, so we've got our stack. So we're going to do our segmentation, or we're going to apply our object-based image classification on our band stack, raster stack, with all of the bands. Okay, so first thing that we have to do in our quest for the object-based image classification is to do the object-based part of the process. Okay, and that implies that we do what we call image segmentation. Okay, image segmentation. So we're going to segment these my image based on certain characteristics, not the spectral signatures, but other like shapes and textures and all of these sort of things. Okay, as I said, for that image segmentation, we need to work with our OTB toolbox. Okay, so in here, you'll see there's a little thing that calls segmentation, a little function that says segmentation. Okay, there it sits. And we're going to click on that. And then in here, there's a number of options. Okay, number of options that we can do. There's large scale mean shift segmentation, which basically is the segmentation. This is what we, by the way, this is what we're going to work with. We're going to work with the segmentation. Just segmentation, you'll see later when we do the second step and the third step. When we do the initial segmentation, when we use this function, we still have to do zonal statistics on the segmented image. If we do the large scale mean, it does the segmentation and the zonal statistics in one go. So this is just a sort of a summary, but just this step and the next step combined. So it's a combination. This large scale mean shift is a combination of this segmentation function plus the zonal statistics. Okay. Okay. So we can use this. But for now, I'm going to just go with this. Okay, so segmentation. So let's open the function segmentation, and you'll see there's a whole lot of options available to us. Okay, so obviously our input image will be our stack raster, this one here. Okay, that will be our input raster. Okay, our input image. We can do the virtual one as well. But for now, let's stick with the stack raster. Remember, the stack raster has all of the bands. So if I go there, I say properties. You'll see if I go saw information, you'll see that's band 1, band 2, band 3, band 4, band 5, band 6, the whole one, tutti frutti of them. And then it gives you a nice little minimum maximum of each. And this is quite important to get understanding. It is 1, 2, 3. There's a fourth. Normally 3 zeros and then there's a number. So the number is normally 30 for 3 decimals or 4 decimal places. For the minimum, maximum, it's only 1 decimal place. Okay, so that's important since we're going to have to adapt these values to those numbers. Okay, so first point first is our input. It's our stacked raster. Then the segmentation algorithm, there's mean shift, CC, water sets, and M profiles. So there's 1, 2, 3, 4 segmentation algorithms. My experience, mean shift and water set is the best of the 4 ones in my experience. And as I said, it's up to you to go and play around with them just for yourself. But it's in my experience, mean shift and water set. Okay, so mean shift, spatial radius, it says optional. It says 5. I leave it normally at 5, but you can go between 5 and 15. But it doesn't make a big difference. But again, play around. Let's leave it at 5. Now, here's where it comes important. This one and this one. Now, these numbers should be relevant to the numbers within your bands. So you'll see there, for example, the mean is 0.08. Mean is 0.2 decimals. There's 3 decimals or 4 decimals. There's 2 decimals. There's 3 decimals, 2 decimals. So the value must be in a decimal. It can't be the size of the value. So I'm going to make it 0, 0.000. Let's make it 3 decimals. So I'm going to do that one, and I'm going to do this one identical. Okay, and I said I make it small. Otherwise, it's not going to recognize that my values are decimal values. So this is actually important numbers. This one, in my experience, doesn't matter too much. You can change it. As I said, in my experience, it doesn't change a whole lot. But these two numbers this is the important numbers here. These are the important numbers. Leave that for default as now. And again, you can play around. Theoretically, there's an impact, but they don't make too much of a choice. So this one and these two, it's not an issue. These two are important that we have it right. Okay, so take note of that. But again, it depends on your data. It depends on your data. Then we can put it as a vector or a raster. Now, obviously, we're going to put it as a vector. Writing mode for output vector file is OLUC. Again, there's 4 options. In my experience, there's no difference. Theoretically, there may be slight differences, but practically, there is virtually no difference. Mask image, if you want to put in a mask image, I just use the stack raster as my input image. So I use the same one as my input image. It's up to you. Many people select it. Some people don't. Um, it doesn't make too much of a difference. Let's keep it selected. The rest we keep the same. Um, total size, starting index. We're going to give all those the default positions. We're not going to change too much of them. I said the only difference, only changes is this one and this one, and then select that. And obviously my stack and mask image. And now what's important here is we have to go and save it. Now it doesn't save to a temporary file. Okay, it does not want to save to a temporary file. Maybe in your case, you're lucky, but in my case, it doesn't save to a temporary file. So for example, if I run it, you'll see it will give you an error. It does not want to save to a temporary file. It wants to save to your folder. So let's go save to file. And we're going to go, where's my folder now? So we're going to go there, YouTube, view from space, and I've got image classification. Now let's just call it segmentation example 1. Segmentation, let's just call it underscore example 1. Now, again, it wants, you'll see now, if I press save, it will tell you file name was not valid. Don't get a fright. It's not the end of the world. Not the end of the world. It actually wants to have the shape file. What do you call it? At the end, achtervoedsel. And I can't think about the English for it. Nope, now I can't think about what the correct English for that is. Anyway, so what it basically wants is you need to put in the .shp. And you'll see if I press save now, then it will give it to you. So it needs that, I don't know what you call it. Can't remember. Can't remember now what you call it. It's called the achtervoegsel in Afrikaans. But now for the life of me, I can't think about the English. Help me. Anybody help me with that. Anyway. So now everything is sorted, everything is done, we're happy with everything, and then we basically just says run. Now depending on the size of your image, it might take quick, make long. This is basically what you come from. This is just a warning sign. It's not really, it doesn't matter too much. Just say there has no data value, 0. And it will sort them out. The rest of it is all good. I'm going to keep this open. So I'm going to go to, it doesn't load it automatically. So now we have to go to layers, add a layer. Remember, it is a vector that we've created, the shape file. So we're going to go into vector. I'm going to go into, need to get to the folder. And then within the folder, let's then give it sort by date modified. Why did it not? Date modified. Image classification. There we go. Sorry, my bad. Date modified. There we go. There it sits. And we're going to say open. We're going to add. We're going to close and nothing. So the question is, why did it not segment? Could it be that these values are again not? So let's leave it at the default 5. Can't be. Let's leave it because these are normally the problem values. Remove. So let's have a look and see. So let's have a look leave it 1. Okay, so let's leave it at 1. Let's leave example 2. You have to play around with these numbers. I don't know why it worked. Layer name, there's nothing wrong there. Let's see now. Again, it's sorted there. Let's go layer, add layer, vector layer, example 2, add, close. So why is it not even? Open that, open attribute table. There's nothing. Remove layer. It says he's done it all right. If it says he's done the only, let's take that 8 off. And let's go back to this. Let's make it, yeah, and let's make that value, and let's run it. Let's make it now 3. I'll delete all these ones that doesn't work and run it. Let's see now. It should take a bit of time. It's too quick. That's the thing. But we'll get there. Vector, and let's say 3. Add. Nothing. Still nothing. That's why that's central. Okay, so let's make that even smaller. 1 there. Let's make that 1. The rest should be all. So make it 4 and run. We have to play around with that numbers. Add layer vector. So that was number 4. We're going to say add, close. Also nothing. That's weird. Why is it doing that? Because what you should have is something that looks like that. That 5 or 15 doesn't make a difference at all. So but just for interest sake, let's make that 15. Mean shift, everything is fine. There's no problems there. Let's leave it back to 8. Let's make it 5. That's unfortunately what we have to sometimes do, is play around with these parameters. Nope. You see, everything is perfectly done. It's not that it doesn't do it. It's just does not segmenting it. I had the same fights yesterday as well. And I played around with these parameters until we got it. Nope, nothing. That's very, very strange. Let's make this also the same. As I said, we have to play around with these numbers. 6 until we get it. Luckily, it's a very quick process. It's not that difficult. It doesn't take too long. You see, it's task complete. It's segmented according to this thing, but let's say add, close. Also not. That is very strange. Remove layer. That is very strange. Why is it doesn't want to do this now? Sentinel stack. So let's close it and let's do it again. Mean shift. Let's keep these values as is. I'm not going to change anything now. Let's just leave it as it is. Save to file, and it's going to be now. just gonna make it 7. Leave it as is. Let's see if it prefers this. Okay, so let's see. It's too quick. That's the problem. So why is it doesn't want to add vector layer? That would be now 7 and add. There we go. Close. There. Okay. So it wanted, in this case, it wanted that specific numbers. Okay. It's strange because at the home it was just the opposite. Here it wants it that numbers. So let's leave it as that. Close it, and then we're gonna go right click, and we're gonna go and say open attribute table. Open attribute table. We're gonna right click. We're gonna say properties. We're gonna go to symbology, and we're gonna say, okay, give it to me in the lines. It's gonna make the lines a little bit smaller, make it 2.6, and we're gonna say apply, and there we go. And there's the segmentation. Now, if we zoom in, you can see it segmented areas that are in similar shapes and textures and stuff. You can see there it is. So there's my image class segmentation. So what you see, there's a long one there. So there's my image segmentation. If I take that away, you'll see there's my image segmentation just for intersect. That's one that I did at home yesterday. There's another one that I did at home yesterday. There's another one that I did at home. Anyway, so there's one example of image segmentation. So let's quickly have a look and see how many of these segments or objects that it identified. If I go to right click and I go to open attribute table, then there's 1004 objects. 1004 objects. So let's quickly go back to it and let's make it 30. Leave the rest alone. Make that example 8 and run it again. Let's see what it does now. So I'm not going to close it because then I don't have to every time open it, enter it. So I just keep it open. So let's have a look and see what it does when we change the parameter from 15 to 38. See if, okay, so there it is. You see now it's got less. So if we go to open attribute table, now it's only got 453, which we don't want. We want, well, you can see it just doesn't make sense. Look, there's one segment object there. That doesn't make sense. Compare that now to when we had 15, the radius, the parameters, this specific number, radius at 30. So let's make this let's make it 5. And then we'll save this as example 9. And we're going to say run forest run, as they say. Okay, so I'm not going to close it, leave it open, and we're going to open layer, add vector layer, and we're going to say 9, and we're going to say add. And you can see there is the one with the smaller radius. Let's go open attribute table. You see it was 1480. So the lower the value is, the lower this value is, that value is the more segments, more objects. For intersect, let's make that a 0 there. See if it makes any difference. I doubt it, but let's not preempt what the results will be. Let's keep it there. Let's run it. Okay. And then let's say view, layer, add layer, and it's going to be number 10. And we're going to say add, and we're going to say open, what properties? We're going to say open attribute. 1480. Absolutely no difference. Absolutely no difference. Remove layer. Um, so the main konijn, the main rabbit in the story is this number here. That the smaller that number, the more objects, the higher the number, the less objects. So how many objects should you have? Well, again, let's have a look at these two. See, there is the 5. And, sorry, there it is. No, where is it now? Now it looks okay. So let's quickly just do form properties, and we're gonna go also green, the line, and 2, and we're gonna say apply. You'll see there is some differences. You can see the differences. So there's the green, there's the red, sorry, and there's the green. So if we now put over there's the red. So let's have a look at this. So there's the red, and there's the green. You see the green is much bigger than the red. So you need to think of, you see, you need to have a look and see which one captures these objects the best. And that's only, you can only do that visually. At this moment, it does seem like the red seems to be better at capturing the objects than, look at this, than the green, which is interesting. Look at the green is much bigger. Huh? So let's have a look at green again, open attribute. Yeah, it's got 400. Yeah, remember we said the green is rubbish because we went to the 30. Okay, so let's quickly have a look at here we went to the 5. So let's do the blue, single line, 0.2, apply. There we go. Now let's look, this is the smaller one, the red. And it's exactly the same. There's one that would add more properties. Let's go open up to this. 148, and this one had come on. This one had open attribute 104. So there should be differences somewhere. Now you see there's the blue, it's got that one there, and the red doesn't have that. So the blue looks, I think there should be one there. So the blue looks better. So I think the 5 is the better option, but that's a visual inspection that you have to do. Huh? That's a visual inspection. So I've already done a lot of them yesterday. And this is the watershed one. You can see the watershed one is much more. Is much. If I go watershed, I could go open attribute. You say it's 71,000 objects. That one there. And this one is another watershed option. Open attribute table is 42,000. Means of segmentation, this one here, properties, open attribute table, that's 1,700. I would venture to say that, you see there's one there. Let's see which one. So the watershed, it's too much. That one is too much. That one seems also a bit too much. That one seems plausible. This one. So that is just working on visual inspection, I would think. And you'll just continue to modify the, see there's one there. Let's have a look. You see that watershed is way too. But again, you can adjust the parameters. captures these ones quite well. See, it captures these ones quite well. That's a means of that one there, that's watershed. See, it does to some degree capture it quite well, but it's a lot, huh? Anyway, and by the way, the watershed, if you go into the watershed, there we go. You just change it to watershed, you'll see the parameters change, and then you'll just change these again. Again, play around with the numbers, play around with the numbers. And that's image segmentation. Now, as I said, what you'll get, let's go back here. What you'll get here is if you open attribute table, you'll just get all the segments from 1 to 1017, that's 104. What we don't have is the band values for each of these segments. You see, each segment here, let's go to this segment here. That segment there, that segment there. You see, if we click on that segment there, that's the whole segment. That's a lot. That's high. And you see, it will have the values for each. We'll have the values for each band. That segment there, because it covers. So what we want now in the next step is what is the mean, median, minimum, maximum band value in this segment for each band. So what is the mean, median value of band 1 for this segment? What is the mean, median, min, max value for band 2? And how many pixels are there in each segment? So that's what we're going to do next. And as I said, if you do large scale mean shift, but you see you don't have an option here in terms of the algorithm. Here it's just a large mean shift. Then what it does, it gives you attribute table that looks like this. So there's the mean value for band 0, the mean for each segment. So this is segment 2. So segment 2 has 96 pixels. And this is the mean value for band 1 of that 96 pixels, etc., etc. You see there's the variances. There's the min, max, mean, standard deviation, etc., etc. So what we next want to do is to generate the statistics for each band, for each of these objects or these segmentations. Okay, so that is, let me just go out there. Yeah, so that's image segmentation. Create something. Now, that just as with pixel-based classifications, it's important. The selection of your training samples is important. Here, your segmentation is very important. And as I said, the segmentation is derived from visual inspection. See, there's one there. There's a big one there. If you click on that, on the segmentation example, click on this one, you'll see that's the outline there. That's actually, you see there's that one there. That's just also, why is it giving you that big one? There's one there. There's one, it's big ones, these ones. There's two there. And there's one there, there's one there. So these are objects. So we segment it. You see, this one doesn't, it's too big. It's way, way, way too big. Whereas this one, you see it is, yeah, it is much smaller. Okay, so sorry. Come on. There we go. You see it's much smaller, the segments. I think this may be too small. But yeah, that's trial and error. Huh? That's unfortunately trial and error. And ultimately, it's about the image classification that we have to look at. So whether this is good or bad, we'll only figure that one out when we do the actual classification itself. Okay, let me stop there for this particular video. It's all about image segmentation, our first step in object-based image classification using the OTB toolbox. With that said, let me pause there for now. Thank you for all your support. Please press all those buttons. Your support means a lot. And yeah, let's grow the channel together. Let's make it happen. And with that said, I'll see you on the other side.